Well, hey there folks, thanks for tuning into the Speaker Builder channel. I've got some repair projects I've got to do today I want to share with you with bass speakers. This first one is a Pro Audio system by QSC, and this is a bass bin much like the bass bin you'd find in your home with an amplifier attached to it, except that this is much larger. You see I put my coffee cup on here, you can see how big this thing is. 18-inch drivers in here. This is probably 2 feet high or something. So, and just in case you're kind of disoriented here by this, it sits on wheels, it rolls around, and the wheels are on the back of the cabinet so that the amp attached to the back, as it usually is, doesn't get subjected to the ground when you turn it up like this. So you roll it around like this. This is actually the bottom. You get the rubber feet that sits on. This, of course, is the front. Drivers in here. So I do play around with a Pro Audio sound stuff, running sound for a church worship team, and this bass driver failed on my watch, and I thought maybe I had overdriven it. So I was felt obligated to try to figure out what was wrong with it and repair it. So we're going to go through that process of finding out what happened with this system today. So again, this is a typical kind of a bass system, exactly what you would find in a bass box in a home system. It's a large square box. It's a little bit bigger than what you'd find in the home, but a square box with a driver in it and a single amplifier in the back. The first thing I did to check this system out is to pull the amp out. Of course, the most likely culprit of a bad speaker is the driver itself, which we're going to look at. It's just off camera here, and so we'll take a look at that. Of course, the driver did fail in this case, but it was a unique kind of a failure. We'll look at that. But first thing I did is pull the amp off. So let's take a look at that. These systems are designed to work on, so this whole amplifier module just unbolts onto the back. I've got this on the sideways. It actually sits up this way, and so it's very basic kind of an amp. Has a AC input, and of course your signal input. I was able to take this out. It has both a 1/4 inch and an XLR, so I was able to put a 1/4 inch input into that and test this out. I pulled the speaker leads along with it. Just simply hooked up the leads that go to the driver to a spare driver I had, a known good driver. Amplifier works perfectly fine, of course. So tested the amp out first. Of course, the most likely failure, as we said, is the driver itself. So let's take a look at that. So here's the driver itself, and as a bass driver, it differs from home drivers, and it has a much stiffer surround than what we're used to having in home systems, because you're going to drive this thing really hard, and with a rubber surround you'll bottom this thing out really easy. So they put stiffer surrounds so you can drive a little harder. So to take this apart, first of all I cut out the center cap. This, of course, whether it's a bad voice coil, what's wrong, you're going to replace it. If you repair this system, you'll have a new voice coil attached to the new cone. So you just cut this apart to take it apart and find out what's wrong. So I took this off and cut the surround, and now you can remove, and then I cut inside here. Now I can remove the cone itself. That leaves us with the voice coil. Let me try to hone in on that a little bit better so you can see that. The next task to removing this voice coil is to cut the spider that is here. But in this case, this driver, given the magnitude of it, it's subjected to such forces that it actually has a dual spider in this plastic ring that supports the 2 spiders. So you actually had to go in here and break the glue seal on this plastic ring, and then this whole assembly comes out, and it is a plastic ring that has an outside spider, and if you can see, the inside spider. So this thing is held in place really well. Okay, so now looking at this voice coil, we see that it is pristine, in good condition. I did, of course, put a ohm meter across here, across the leads, before I took it apart, and determined that in fact there was no failure of the voice coil. Usually it'll blow. Sometimes the lead, if you can see the leads going to the voice coil, sometimes they break right there when you overdrive them. But more often I've seen when drivers are overdriven, they get really hot, and the color will change, and they'll get really black and nasty looking. Now, originally what I discovered is with this driver, that it was ordinarily you can move the cone up and down inside the basket. And this thing was locked in place and could not be moved at all. So that was a real surprise. And it indicated to me that the voice coil had failed so badly that it had distorted its shape and locked into the very tight gap that it sits in the magnet structure. So I thought that it was a real bad failure of the voice coil. But as we see, the voice coil is perfectly fine. So the good news is I did not overdrive this thing and burn it out. So something else happened. That's really strange. So I'm going to look at some other little drivers, because what we've discovered is that the magnet failed. So let's look at how, and I've actually learned this over the last couple of days, how the magnet is actually structured, because this had a structural failure of the magnet. So let's look at a smaller driver so that we can kind of see how the magnet's formed. So here's a small mid-range driver, and just for the sake of understanding how speakers are designed, if we pull this around, and again, the next step, I would cut the single, these usually have a single spider, and then you have the voice coil, and I cut the leads. And now the magnet system incorporates a center ferrite magnet, a lower steel a plate on the bottom of it, or the back of it, and then a steel plate in the front, and then oftentimes that steel plate is drilled and threaded, and there are screws that go in to hold the basket onto the magnet. And you see these are just have formations of the front metal plate that actually are opened when the basket is put in place, so it's not using screws, you know. But anyway, that's basically how it's designed. And then so the magnet then has three pieces to it. Actually, it has again the back steel plate that incorporates this protrusion. It has a front plate, and then it has, of course, the ferrite middle. Now I took one of these apart. You can kind of see the three parts. And here with this one, you see I've hit it with a hammer and chisel to take it apart. And you can see the two steel plates. The front one has the protrusions where the basket sits on there. And it is just bonded to the ferrite magnet. And it's so strongly bonded that I could not separate it. The ferrite magnet broke before that bond would fail. So this steel plate is bonded to that ferrite magnet and located, of course, very precisely, centered precisely. And then the rear steel plate has this protrusion. The protrusion is the extends the magnetic force so that the voice coil, of course, rides on that. It doesn't ride up and down very low anymore, but you know, that's the idea. It sits down there in a very, very small gap. That's, of course, completely free and clean, as this one is no longer, but anyway, that's how it works. So this steel plate, I can put this together and show you. So that, oh, that's very tough to, but anyway, so two steel plates and a ferrite magnet in the middle, and these steel plates are bonded to the ferrite magnet, and they wouldn't ordinarily ever move, ever come off that ferrite magnet. I've never seen a case where the bonding failed. Well, so here's the magnet for our 18-inch bass driver, and you can see this is the ferrite magnet. This is the steel plate on the back, and this is the protrusion where the voice coil rides. But you see that the front plate, the front steel plate, is no longer bonded to the ferrite magnet. And here is the front plate with the holes drilled and threaded to allow the basket to be mounted on there. And of course, you see that front plate is no longer bonded to the ferrite magnet. That's a problem. Very surprising. You can see, I don't know if you can see this in the video, there's a place where you can see where the glue starts and stops. There was a bonding material that was put on here. This is going to grab on here because this obviously is steel, and this is a magnetic, huge, very powerful magnet. So I can't put this back on there without it grabbing on, and I'll never get it off again. But the idea is that there was a glue material put on a glue material that was applied to the ferrite, and then applied perhaps maybe to one or to both, and then this was placed onto this And as you see, it gets on there and it's very hard to get off. But anyway, so I can't put it on and show you, but the glue failed, and that's the big surprise. Now, if the glue fails, what will happen is this thing will no longer sit centered as it should. In fact, it will. You see, when this magnet is so powerful, and this is just steel, so this magnet is grabbing the steel even as I'm trying to do this video. So with this thing sitting on here, in this position, sitting on this magnet, it will. I'll try to do it up here. I'll try to show you. It would sit, but it would no longer sit. See, it's pulling on my hands as I do this, but it would no longer sit centered. It will remain attached to the magnet, so the back of this magnet doesn't just fall off when the glue fails. It will remain on because the magnetic force will hold it in place, but it will shift because there's a gap between this inner hole and this inner steel where the voice coil rides. There's a gap between those two, and so when the glue failed, this naturally is going to shift to one side, and this steel will grab onto some portion of the steel. At some point it could shift in any position it wants, but it will shift, and of course the voice coil is riding down there between there. So when it shifted, actually the magnet shifted, whatever, but when it shifted, it jammed the voice coil into place, so the voice coil, of course, could no longer ride up and down, and so bound up that voice coil. I have never seen a failure like this. So with this one here, you see that. Again, that steel plate should never have, this is the front plate here, but that steel plate should never have come unbonded from that ferrite. This bond is so strong. In order to separate that, I end up breaking the ferrite. So very surprising, that kind of a failure. So that's what happened. Now, to repair this driver would involve getting a new cone with a new voice coil. But I would have to re-glue this steel plate, and that would be very hard to do. And I wouldn't attempt to try to do that without the proper kind of a glue. And then who knows what would work and what doesn't work. Obviously, the glue they used for this driver did not stay for, this is about a 5-year-old driver, so it didn't last for all that long. Now, this driver was being taken out and stored outside for the past 6 months in cold, and so it was subjected to some temperature variations. But I honestly can't believe that those temperature variations was the most significant factor in this failure. I would have to say this glue material should never have even come close to failing, no matter what this thing was subjected to. So, big surprise here. The only solution is to replace the driver completely. That's not cheap, 300 bucks, but it's not the end of the world. It's not an unbelievable cost. So that's all with this driver. I'm just, the putting in of this driver is very, very simple, so I'm not going to really cover that. It's just a bunch of Phillips head screws, and you connect the wires on. So it's nothing really to spend much time on here. The other repair project I have here is another bass driver, and in this case, I haven't burned these up. This has a massive magnet and so forth, but what happens commonly with these drivers, I don't know how common it is, but with these, I'm using pretty heavy-duty cable to connect the wire up. This is a dual voice coil, so it has a connector to hook up the two voice coils. But what happens with these, if you can see that, the little connectors, the material that's used to hold these tabs on fail. You can see me moving that. So, and I guess just what the deal is that with heat, the amount of heat, I'm using a very heavy iron because I'm dealing with heavy wire, number 12 or 10 wire or something. So repeated times of heating this spade connector overheats the little piece of material that holds the thing in place, and it'll fail over time. But of course, you're pressing on it, and the pressing and the heating of it combination causes these to fail, and so that's not good. I've had to repair one of these already. I'll show you that. This is my first attempt at a repair, and I had to take a piece of plastic and then remount these spade connectors. I had to drill the holes, I used pop rivets, and I used a pop rivet here. The material has to be of such that it is both strong and unable to, of course, transfer electrons, because these connectors obviously could not have. So in other words, you could not make this out of metal or something really tough. Can't make it out of wood. It's got to be a plastic. What they use, I think, is kind of it's a hybrid kind of a plastic material. I've also seen it's a pressed paperboard kind of a material used for these, but they're not very tough, and they don't tolerate a lot of pushing down and getting real hot. They fail over time. So this was my attempt at a repair, but this is being a dual voice coil, and I have 2 of them. I need 4 of these repairs. And this was difficult to replicate. So I decided to look online, and I found these connectors. These are exactly like the ones that were used in the driver we just fixed. And they're nice red and black, and they're pressed down, and you push them down, put the wire in, and so the bad news is on these, this is an, you see this, it's a open core. Well, it looks like actually it's got enough metal on there. The idea is you want to really grab onto a whole lot of wire when you connect these up. So this actually is, they work pretty good. The issue is that if, as opposed to a screw down nut, as we see in some amplifiers have wire connectors on the output of the amp, and there's a screw down. The trouble with the screw down that over time they tend to get loose. The wire settles in or whatever. The nice thing about a spring-loaded device is that it constantly puts pressure on that, so that if there's any loosening, it will continue to hold pressure on there. The idea, this is what's called a gas-tight connection with a spring-loaded device, as opposed to a soldered connection. And these are, the soldered connection's okay, but gas-tight connection is preferred. Trouble is, of course, you're going to have a soldered connection between the voice coil leads in here, so you're not eliminating solder. But anyways, these are about $5 a piece, so they're not cheap, but they're a really nice way to go. And so we're going to do this repair. I'll probably put this in this way. Well, I can't put it that way, can I? Because I've got to have plus over here, so I'm going to have to bend this around to hook up the wire. So let's go ahead and do this repair. First up, we've got to drill these out. Well, before I drill those out, actually, I've got to take the wires off first. So I've got the iron hot, and we're going to peel these wires off. Now, when I'm doing this work, what we're going to do is tip this upside down, right side up or whatever, so that if solder drops, it doesn't drop onto the cone. So it drops this way. So we're going to turn it upside down, right side up, to do this repair. So the lens is wide open here. It's a pretty narrow depth of field, but so we're going to go in here with our needle nose. I'm going to grab that wire, then we're going to heat this. That wire should come right off. There we go. So that wire is removed. Now we'll remove the other one on the other side. First of all, I've got to get this wire off here. Then we'll go in here and grab this wire. Remove that. Now, since I've got the iron in hand, I'm going to go around and do all the others. One of the other things I'm going to do here to keep track of things is I'm going to put a plus here. I can do that with my right hand. And that tells me that this side is plus because I've already marked it. Same thing on the other side. This is a dual voice coil, of course, and plus is on this side. And these, you can see the little red dot that tells us plus and minus. In this case, sometimes they're marked with a little plus and a minus on the material, but that's how we tell what's plus and minus. Don't want to get polarity backwards. And the next task then is to remove this, and to do that, this is a pop rivet or a rivet of some kind. So we're going to have to drill this out to remove this so we can mount the new device in place. What I'm going to do is start with a small drill to drill a pilot hole right in the center here. And then we can use a proper size drill that's going to enable us to remove that. So we're going to get it right in the middle here and start our hole. So I put a piece of wood in there to keep me from slipping and going into the cone, of course, right? I got our pilot hole started, so now we're going to get a proper size drill. Let's see. That's probably a good size. You can always drill it out a little bit further if we need to. And that's all. We're going to go ahead and drill out all of these since we're drilling. This one I've repaired already, of course, once, and so I don't know that this drill size will be adequate. I'll have to use a little bit bigger a drill for this one. Now I got to vacuum up the mess I made. Get in here and clean up all that drilled material that's inside the speaker now. So I think we're ready for phase 2 of the project, and that is to get these mounted on here. We've got to solder the connections first. We see the advantage of marking which one is plus now, because otherwise how do you know? So we're going to mount these. We're going to figure out how to do this. Again, I can't do it this way, so I've got to do it that way. I'll have to bend these tabs back down again, but first thing we need to solder those leads onto these. And so we could do that upside down, and that would keep solder from going into the driver. So that's probably what we're going to do. Next step we have is to secure this hardware. I bought some 832 screws and these locking nuts that have a little nylon washer in them, so that when they're tightened they stay, they don't go anywhere. So the hole here isn't quite big enough. We're going to have to drill that out just a little bit. We're going to do that before we try to mount these. So that's what we're going to do. I'm going to put my hand in front of the camera so you can't see me do it, but that's what I'm going to do. The hole I drilled doesn't quite give clearance for that screw, but I can crank that screw in. Since the material is made of plastic, I can easily crank the screw in. That will hold that screw in place pretty well, and that actually would be preferable. So we'll put in, cranking that screw in, and it kind of stays in place. Now the only other question is whether that's the hole in our plate in the speaker is large enough. If not, we have to enlarge in that hole. And here's the plate. You can't, it's straight on to the camera, so it's hard to see, but that's the plate, and that's where the hole is, and this is our new mount with the screw, and it looks like it fits perfectly. So we'll be able to put that nut behind there. But I think I want to solder these wires onto the connectors before I mount it. That's what I'm thinking. So I'm going to do that next. So we're going to put some solder on these connectors using a little bit of a solder paste. This solder paste is a zillion years old, actually. We're just going to fill that little gap with a bit of solder. This iron's probably a bit overkill. This is I think the 40-watt iron. It's probably overkill for this job. It was necessary for the to get that other wire off. But so now we're ready to go. Keeping track of plus and minus, of course, again, so we're going to solder that in place. Let's see if I can get a soldering iron in there and without having to hold on to that. Every once in a while, the soldering iron tip, the core of it gets so bad and it blackens up, so I've got to hit it with a file, redress it, make it nice and flat and clean again. I can go back and start working again. So that soldering job looks pretty good. I hope that's in focus. That soldering worked out pretty good. So now we're going to have to turn this 90 degrees. We're going to move the plate up a little back to its original position for mounting, and then we're going to turn these 90 degrees. I'm going to have to be turned more than 90 degrees to mount that in place. The idea being that that wire needs to be able to travel up and down, that cone moves up and down without any interference or problems. So we're going to bend those tabs down. They're nice and strong and can tolerate that. I think we're ready to mount that in place. I just got to put the nut behind it, get it started. I have to do that with my hand. Easier said than done. Hold the nut in place with your finger and start the screw. And get the threading to start. And it has started, so now I'm going to put a wrench on that. Reason for using that, it's just much easier to manage the amount of tension this thing is subjected to, and make sure it doesn't walk around too much, because I can really crank it down. So now I'll put a wrench behind that, grab onto that nut, and then I can take my screwdriver, get in there, crank that down. So there's a first successful repair. Let's turn that over. We'll get a better look at that. I know my depth of field is pretty shallow here, but anyway, that's the repair. You got plus and minus. And of course I made sure I got my polarity right because I marked it. So we're going to shut the camera off and do the rest of these repairs, and then maybe I'll come back and look at that. So here are the speakers finally repaired fully with all the leftover pieces that I ended up with. They look pretty good. They came out pretty good. I think these drivers warrant the expense here, $5 a piece for these, again, from Parts Express. So one of the ways to check the repair to make sure it's actually working is to do a continuity test. You could do that with a meter, or a real cool way to do it is with a battery. So we're going to do that. How we do that is we take a couple of test leads and we're going to plug in test leads into the connectors like so. Now we'll turn this over so we can actually see our test happen. And I apologize again, shallow depth of field, but anyway, you're going to get to see the speaker move. Now what we're going to use is the This is a rechargeable battery. The reason I'm using this one is because it's only 1.2 volts. You don't need a high, they say to use a 9-volt battery for this test. I wouldn't put 9 volts through the voice coil. You don't need that much voltage. When I do this kind of a test, I want to use the lowest voltage batteries possible. So what we're going to be doing is with our test leads, we're going to be putting the battery across the test leads. It actually puts a voltage through the voice coil, and that voltage will create a field that will act against the permanent magnet and drive this cone either up or down. So watch what happens. Polarity doesn't matter, of course. We're going to do black on plus on the negative, and then on positive, and then watch what happens. You can see that speaker move. If you do it the other way around, of course, it'll go the other way. It'll go down instead of up. Anyway, good way to test continuity. We can do the other side as well. I'm very confident in my repair, so I'm not going to bother to test them all, but I wanted to show you that if you wanted to do a test when you do a repair like that, just to make sure before you actually install the speaker and get all excited and then discover it doesn't work. Very easy way to test that with a battery. That's about it for this repair job. Leave comments if you'd like. See you next time.